carefully. So here you are given the diagram, and then we have a parabolic function which is given by f. Okay? And then you want to check all the points that are on f so that you know which, if they ask me about this point, I am going to be concentrating on f. So what are the points that are on f? You can come and check here. We have D, it's on f. Okay? Yes. We have E, which is also on f. We have A is both on f and then it's also on G. Okay? Yes. So I can either use G, I can either use what? F. It doesn't matter. And then if you go through the statement, they say the graph has the x-axis at A and C. So the graph of f cuts x-axis at A and C. So these are the x-intercept. Y should be 0. You can come and put it there. And then they say it cuts the y-axis at E, and then it has a turning point at D. We're not guessing all these things. I think they're given. And then the graph of G cuts the x-axis at A. Graph of G cuts the x-axis at A. And then the y-axis at B. So B, it cuts at A and then and B. Now the first question says, write down the equation of the asymptote of G. They're being specific here. Okay? Go and look at G, because they know F doesn't have an asymptote. They're not going to be talking about an asymptote when they talk about F. Now, what is going to be number 1 then? On number 1, we come and look at the following equation. Okay, go and concentrate on the equation of G. Here's the equation of G. On the equation of G, what is the asymptote? Is whatever the value of Q is. Okay? Yes. What is the value of Q then? Then you will say Y is going to be equal to what? And then you get 1 mark. Number 2, they say write down the coordinates of D. What is D?
Turning point.
It's the turning point. Okay? Now, where do you get the turning point? You get it from F. F has a turning point, and then this thing is already given in a turning point form. I think we can be given a parabolic function in a turning point form and not in a turning point form. This one is a turning point form. So how are you going to get this thing in number 2? You're going to say x minus 3 is equal to 0. Okay? It says which x is going to be what to be 3. And then the coordinates of the turning point, which are D, you're going to say it's 3, which goes with whatever Q is. What is Q then?
25.
And then you see this thing, they're not like it's 2 marks, it's 1, it's 2. Now, number 3, they say determine the range. Now, what is the range? The range, the maximum value that you can have is this one here. I think you have 3, which goes with what? With 25. So your graph is going to be divided into 2 parts here. There is before 25, and then there is after 25. After 25, you don't have anything. So your graph is going to be divided like this. You have 1, you have 2. Okay? Yes. Then you have before 25, and then you have after 25. In graph, where do you see the graph? On 1 or on 2? On 2, okay. Values that are on 2, are they bigger than 25 or they are less than 25?
Less than 20.
So you're going to say here on number 3, y is going to be less or equals to what? To 25. You don't have any graph above 25. So you do have a graph from less than 25 going up until you go to infinite. Let's go to number 4. What are we doing on number 4? On number 4, we are determining EP. Now we are looking for E, and then we're also looking for what? For P. They already told us what is P. They already told us what is E. If you are not sure, go and check there. They said E is the y-axis with E. So F intercepts with the y-axis at E. So it means what E is the y-intercept of F. So if you want to get the coordinate of E, you're going to say you have y, which is going to be given by minus open bracket 0 minus 3 all squared plus 25. And then you type this in your calculator. If you type this in your calculator, you get what? 16. Okay. You come and say which you have 16 again. What are going to be the coordinates of E then? And my coordinates for E, you have 0, which goes with what? 16. We are still fine again. Okay, what else do we need to know? We need to know what is going to be this thing here, which is the y-intercept. Is the y-intercept of what? Of G. So if you want to get this one, you're no longer going to use F anymore, but you're going to use what? G. Let's go and use G then. If we use G, we're going to say which we have y, which is going to be equaling to, it's 2 again, multiplied by 1 all over 2 to the power of
0 plus
0 plus 1
minus 5,
minus 2.
minus 7,
Then the answer that we get, it says it's going to be what?
minus 10.
And then we come and say, but this one here is simple. This one here is going to be minus 3. And then you have 0, which goes with what? With minus 3. Now, that's not what we're looking for. Now, we're looking for the length again. Now, in length, yeah, if you are dealing with a positive and a negative, you add. If you are dealing with a positive and a positive, you subtract. Let me just give you an example of what I mean. Let's say the point P was here. Agree you're on the positive side. Now, you're going to say which top minus the bottom. But if you are dealing with a positive, I think this one here is positive. Can you see that one?
Yeah.
This one is positive, and then this one here is what? It's negative. So if you have a positive and a negative, to get this length here, you're simply going to say it's 16 plus 3. And then it's going to give you what? 19. And then we said this again. I'm going to say it again. If you don't understand this thing, guys, put this thing here on a distance formula. I think you have 2 points here.
Yeah.
The coordinates of E also have the coordinates of what? Of B. And then if you put it in this equation here, you will never go wrong. I think you're going to have x2 minus x1 plus y2, yeah, all squared. Y2 minus y1 all squared. And then you put in those things there, it's going to give you this thing here, which is going to be 19. Okay, we go to number 5. On number 5, they're asking us which is determine the values of x for which f is increasing. Yeah, I wanted to teach this one now. F is increasing and f is decreasing. Okay? Now, f is going to be increasing and f is going to be decreasing. If you compare this value here, we are looking at the y values. No? You're going to be looking at the y values. If you compare this value and this value here, would you say this value here is increasing or decreasing from here to here? What happened? Are we increasing or decreasing?
Increasing.
If you compare this y is negative. Okay?
Yeah.
This y here is what? It's positive. It's positive. It's getting bigger. Okay? It's getting bigger. 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 Up until you get to the turning point. Let's get here. We know which one is y here. When I'm talking about the graph is increasing or decreasing, I'm looking at the y values. Our y values they can either be increasing or decreasing. Okay? Now let's check here. You are at 25. If I go here, do I have a value bigger than 25 or less than 25? Less than 25. So if graph from 25 is starting to do what? To decrease. So if graph is increasing up until to the turning point, okay? At the turning point, it starts to do what? To decrease. So what do they want? They want where it's decreasing. Okay? But they want to know what are the x values that are making that to be possible. So when results are like, okay, x is a vertical line. This is this. So if graph here is going to be decreasing here. And the graph is decreasing here. Okay? Now we want to know which one is x here. X is 3 here. Okay? And then we have 1, we have 2. Yeah? Now, in graph here, we don't have a graph that is decreasing at 1. Okay? We have a graph which is decreasing at 1 at 2. Values are here. What should you say? Are they bigger than 3 or they're less than 3? What should you say? Ama values are 2. Ama values are they bigger than 3 or less than 3?
Bigger.
So I'm going to tell them the graph is going to be decreasing when x is greater than 3. So when x is greater than 3, the graph is going to be what? To be decreasing. And then check here, I didn't say greater or equals to 3 again. At 3, graph is not decreasing, it's not increasing. It's stationary, it's at the turning point. And then at less than 3, your graph is increasing. At greater than 3, your graph is doing what? It's decreasing. Yeah, your graph is decreasing. Yeah, your graph is increasing. The graph, guys, we're confused. Our x values, we don't care about the x values. When we talk about the graph is increasing or decreasing, we're talking about the y. You check what is happening to the y values. Because I can say, Jay, you're looking at me, but here, if you go here, we're going to smaller values of x again. Yeah, we're going to smaller values of x, but the graph is not increasing by x. The graph is increasing by what? By y. Yes. Yes. The graph is increasing. Yes, it's getting big. I say what?
When you include that graph is going like this.
I said-
I say now the graph is going up.
The graph is going like it's increasing, and then it decreases. So when you have like, okay, the other way to think about it, if you have a set phase, your graph starts by increasing and then it stops and then it decreases. If you have a smiling face, your graph is going to start by decreasing, and then it stops again. And then start to increase. When you are mentioning the x values that are making that to be possible, like, yeah, I'm x values, you're always going to start from the negative and then you go to what, to the positive. I'm stopping here.